Thanks everyone for coming. I'm glad the fire alarm didn't scare off most of you, if some of you had came in a little later. Be careful maybe not to use this door or something that triggered an alarm afterwards. So welcome to this session. Welcome to Amsterdam. My name is Kyle Weller. I'm a product manager on the Azure Databricks team. As most of you may know, Databricks, of course, it's also on Azure. Microsoft partners with them to build Azure Databricks and make it the best Apache Spark offering we have on Azure. So today, we're going to talk about the applications of time travel with Delta Lake. So I want to gauge the audience just a little bit. How many of you have used Delta before? Yeah, okay, fair number. And how many of you have used the time travel features functionality? A lot smaller number. Okay, good. That's probably why you're here. You want to learn more about time travel and get into some of these. How many of you have heard of time travel, though, before? Yeah, okay, yeah, good. All right, so I want to start off just talking about a question. So with all of the amazing technology that we have in 2019, Apache Spark and otherwise, Gartner still estimates that near 65% of big data projects will fail. And I want to get some feedback. I want to get some ideas from the audience on what you think. So let me switch over to a little poll tool here. Let me flip out of this. And so everyone should have cell phones or some other kind of device. Log on to this tool, menti.com, throw in that little code up there. I want to hear what you think on how you have seen big data projects fail before in your organizations, on your teams, in your companies. How have you seen big data projects fail? Is it from complex data? You're dealing with complex types of workload streaming, machine learning, these kind of things. Do you have complex system integrations, getting all the pieces to connect and work together? Maybe your data lake is a swamp. You're dealing with messy, unreliable data. Is it about performance and scale? Can you not scale to meet your needs? Does the company have budget restrictions that maybe you get halfway through a project and you're not able to make it through? Organizations not aligned, maybe it's because of multiple teams or organizations within the company and sharing data between them is hard, or maybe it's organizations like your different leadership teams or security teams or otherwise that make it challenging to build these big data projects. Hit me up on some votes. I think when you get on the tool in there, you'll have 100 points to allocate, tap a couple times on the ones you want and hit submit. So it looks like we got a good number coming in here. On the top, organizations not aligned, great. Complex system integrations, performance scales at the bottom, that's good to hear. Afraid of the clouds down at the bottom, that's good to hear. You guys are fast, we got 60 responses in here pretty quick. All right, good. So I'd love to chat with some of you afterwards as well to learn more about your thoughts and opinions here, especially seeing organizations not aligned. It wasn't one that I expected to be so far ahead near the top there. So I'd love to chat with you more afterwards to learn. Let's dive back into this. And let's talk about, let's set up some of the complexities that Apache Spark is helping us to solve. So some of those were in the list previous. Obviously, dealing with complex data, diverse data formats, data that can be dirty, out of order, late. You're also dealing with complex workloads, machine learning streaming, complex systems. You're going to be connecting Apache Kafka, other storage technologies, data warehouse technologies, and you're going to have to deal with building resilience, retry logic, and being prepared for when system failures come in the mix. So Apache Spark and Databricks as well help to solve some of these things. But there's some challenges that are still there, that are still present, that you still have to deal with. And hopefully these sound familiar on what we're building up to with Delta Lake. But concurrency, when you have multiple readers and writers, trying to ensure that you have atomic transactions, the small files problem and performance degradation that comes with that. Updates and rollbacks, everyone has to deal with GDPR, user delete requests, and very often, sometimes you may need to roll back or reprocess data. These can be challenges. So that's where Delta Lake comes into the picture. And so I think most of you know the basic premise here. Of course, everyone hopefully was at the keynote. Mike Armbrust did a much better job than what I'll do here at presenting Delta Lake. But here with Delta Lake, we get ACID transactional guarantees. Some of the secret sauce, do I have a pointer? No laser pointer. So the secret sauce behind this is you have, it's still using Parquet file formats, and it's versioning these files, and it's building a transaction log with indexes and stats around around those files, so you can have fast and efficient access. The transaction log, along with the version files, this enables you to achieve those ACID transactional guarantees. You also have this snapshot isolation, so you can get concurrency with readers and writers happening simultaneously. You have immediate rollback capabilities that will come into play with time travel a little bit as well as we go through. And there's also the ability to do efficient upserts, so a combination of updates and inserts. There's some merge commands and some other things with Delta which make this really great. And then, of course, time travel. That's what we're going to spend more time talking about here today. Okay. Of course, Delta Lake's really easy to use, really easy to get started. Everywhere where you were saying using Parquet, using JSON, using CSV, flip those over to say using Delta, and it's ready to go. So Delta Lake with time travel. So time travel with, you've got the version files, and the transaction log that's keeping track of everything. And now you can write statements that say, select my data from this table as of a particular timestamp. And you can go back in time and reference that. You can say as of a particular timestamp, as of a particular version, a couple different ways to do that. So some applications of this time travel, what it is that you would want to achieve or that you'd want to do with time travel. Some of these include being able to audit data changes. So in the transaction log, I'll show you as we go through the slides, you can describe all of the transaction history that has happened into a table. And see what exactly is going on there. Data reproducibility. This comes into play with machine learning. If you're tracking some ML model drift and you need to retrain that model on exactly the same data that you trained it on previously. Data pipeline debugging. So oftentimes as a data engineer, something will go wrong in the data pipeline and you're going to need to go through and inspect and analyze and try to figure out what's wrong in the system. We'll do a demo with some live debugging there as well. Immediate rollback capabilities. There's a slide we'll go deeper on that. So auditing your data changes. Here's a screenshot. Yeah, I think you guys can see it. It's pretty large on the screen there, where you can see a table where we say describe history on this events table, and it's showing us the version, the timestamp. You can see which user ID, which username, the type of operation, parameters in that operation, if there's a job ID associated with that, which notebook it may be coming from, cluster, versions. There's a lot of information there. But even just understanding maybe which users we're writing into this, which jobs we're writing into this. Think of the applications that might be here. Maybe it's auditing for compliance kind of purposes. Maybe it's auditing for security and ensuring that you're meeting the security requirements set forth in your company. Data reproducibility, we talked about this where you need to go back and reproduce the exact same data that you were using previously. We talked about how when you're training ML models, it's really important if you see that model drift, meaning that the data is actually changing underneath, and you may not be receiving the same accuracy in those models as you previously were. Now you can, if you need to retrain, you can go back to the same baseline, retune the parameters, and you can get a much better experimentation, A/B experimentation, and retune that model to get it up and running again. Let's talk about rollbacks. So time travel makes it easy to do rollbacks in case of bad data. You can see here this example is even just rolling back data for one particular user ID. We can say insert into your same table as you're selecting it from an older version. This is just referencing the previous version. and it's only rolling back for one particular user ID. So now you can imagine some of the ideas of different where clauses or different ideas on how you can roll back data. You can also fix incorrect data, or maybe you want to use these statements even for processing GDPR requests. You can say merge into my table using that same version in a previous timestamp, so going back in time on that. And you can, with this when match clause, you can update, you can delete, you can do a couple of options there. Okay, so that is some of the basic principles of time travel. Now, if you're going to be using Delta Lake and if you're going to be using time travel, we also want to talk about how you may want to scale in the cloud, how you're going to want to take Delta Lake and go into the cloud. So obviously, I may be biased a little working at Microsoft and working on Azure Databricks. But here with Azure Databricks, everyone already knows what Databricks is. But basically, it's the clicks of a button, fully managed Spark experience. When you use Databricks on Azure, you get enterprise-grade security that's easy to use, built-in Azure Active Directory authentication for role-based access control. You have financially backed SLAs, a lot of extra functionality that you can achieve. With that, I wanted to show just a general architecture, just a general overview of where Databricks fits into your whole data pipeline, and also where Delta comes into play. So at the beginning here, you're dealing with a whole array of data, whether it's sensors and IoT data, unstructured logs and raw media files. It could also be coming from regular line of business applications. You're going to be ingesting this data. We have several different ingesting type of tools that you might want to leverage. Azure Data Factory has 70 plus connectors built in if you want to move data into Azure Data Lake storage. You have real-time kind of tools that you can use. Of course, Apache Kafka is super popular. There's also Azure Event Hubs, which now supports a Kafka protocol head, so you can write all your Spark code as if it was just talking to Kafka, and then you can have a fully managed service. Azure IoT Hub as well. You get this into Azure Data Lake storage, and then you're processing it with Azure Databricks, maybe leveraging the Azure Machine Learning and ML Flow integration that we have. And then you're sending it out to some kind of serving layers, whether that's Azure SQL Data Warehouse, Cosmos DB, sky's the limit on that end. So Delta, where it comes into play here, just because you always want to remember that Databricks is a separation of compute and storage, Delta comes in here where you're transforming that format of the data from this raw format to the Delta format, bringing reliability to your data lakes. So here, let's do like the next level down. That's a pretty high level view of it, and let's walk through. So step one, you're loading that data into a data lake storage, and then we'll go through this bronze, silver, gold concepts. You probably all heard this before plenty of times. Michael and Barak were both referencing it in the keynotes as well. So you're going to combine batch and streaming data, and you can save this in Delta format. So then right away, you've gone from that raw format to this Delta format, and you didn't add any business logic in between these layers. And the key here is then, if you need to do any reprocessing, if you do need to go back to exactly that raw data, you can go back to this optimized format, this Delta format, where you've ensured reliability with schema enforcement and other pieces of Delta. Then from there, you can start joining, enriching, cleaning, transforming this data, maybe adding some business logic as well. And maybe you're into this concept now of this silver table. These are just rough hypothetical concepts. You can then use Azure Machine Learning, ML Flow, create more higher level aggregates of your data, business level aggregates, and be creating these gold tables. The idea here is just to show that there's these multiple stages in the pipelines. And what you're enabling in these different stages is, we talked about the concurrency, isolation, these kind of things. So now you've enabled anyone at your company, any organization, we talked about organizations not being aligned within the company. Maybe it's because of democratization of data, maybe some other areas. I'd love to hear your feedback after the session as well. But perhaps as we save this data in the Delta format, and now that we've enabled concurrency, now many users across the organization can come and read this data simultaneously and all have the same version as they're doing so. Now you also are able to achieve that at these various stages. So that's kind of the idea behind this multi-stage pipeline. All right, let's flip over and do some demo. Let's make it come alive, okay. All right, I'm gonna execute a couple cells ahead. Actually, I'll tell you the story first. So today in this demo, we're going to use time travel to reduce carbon emissions and save the world, right? This is a big thing that we want to go after. So I'm not a climate change expert. I'm not an economist. I'm not any of these things, so disclaimer on that regard. But I was doing some reading, some interesting reading, and I found this policy here, this EU emissions trading system. Has anyone heard of this before, the EU emissions trading system? A couple hands, great. So I learned about this recently and thought it was interesting. So here's the official webpage here, the EU emission trading system. It's aimed at, it's a policy to help combat climate change, obviously. They call it a cap and trade system. What this means is that there's a cap set on the total amount of greenhouse gases that you're allowed to emit. And this cap is reduced over time, so we're forcing the reduction in the carbon emissions. But in this trading kind of system, it allows companies to trade with one another as needed. So now imagine the economics that are play in this factor, where you are now incentivized as a company to reduce your emissions, reduce your carbon footprint faster than that cap is declining. Because if you do so, you now have these credits, these allowances that are freed up, that then you can sell on the market to other companies. So not only did you reduce your emissions and your footprint, but now you can make more money by selling these. Of course, in a system like this, there's going to be a lot of monitoring, reporting, compliance. So annually, at least in this system, annually they have to send a emissions report that needs to be reviewed by a central authority and approved to make sure people are doing this accurately. So we're just going to do a little simulation of this in the demo. I'm using this IoT demo that's built into the Databricks file system with all the workspaces, so you can come and reproduce this same demo. And that's this IoT device stream. So it's not really built for this purpose, but we're going to use it. You'll see in this stream of data, there's a device ID, device name, IP address, some location information, and down in here, hidden in here, there's these CO2 levels. So here, this is, imagine these are sensors distributed all over the world or for certain companies that are measuring their carbon emissions. So what we're going to do is we're going to take that stream of data. I actually have a simulator that's running in the background. Let me make sure it's running here. I'm going to restart it. I have a simulator that's basically, if you want to see it, it's just taking that stream of data in a loop. It's writing it to event hubs, just so we can set that up as if it was actually running. And then I'm going to set up the connection strings to that event hubs. And event hubs, the architecture is really similar to other messaging buses that you have out there with multiple partitions, consumer groups, etc. Now we're going to use spark.readstream, pass in that event hubs connection string, and load that in. And we're going to take the body, cast as string type, and write it down to our first location, being this bronze path. So this is going to start streaming in. Let's take a peek at it as it comes through. All right, so you can see the data streaming in through here. Let's see if we can even watch it reload, yeah. So it's streaming this data live as we go. Now we can do some more formatting, some more cleanup, some more processing on this data. So we're doing some parsing, we're doing some typecasting, we're adding a couple new columns into this data set, and then we can write this down into our second checkpoint here, this silver path. As this writes, let's take a peek at it. All right, so now this makes a little bit more sense to our eyes other than reading this stream of string arrays here. Now we can see the full table. We can see that this particular sensor is in the USA with this device name, IP address, etc. These are streaming through in real time. And I've slowed these way down. I think I throttled this just for a couple events a second. So let's look at the levels, those CO2 levels as they're coming through for the devices. So we're going to do a sum of the levels, grouping by device type and timestamp. Just plot these real simple. All right, we can see this data flowing through. It's a little bit messy. You can see these carbon emission values for different device types, and they're hovering between 1 and 1,500 values there. I'm not sure of the units that it's measuring. And now let's watch this stream carefully because we're going to simulate a failure. So let me flip over to this, hit run all. We're going to simulate a failure and watch what happens to this data. Make sure this is running, good. All right, because we're going to see some of the older data. All of a sudden, this older data is going to spike up unnaturally. So let's give it a second here. Okay, so now we see some of this older data has spiked up almost double or near double the previous values. And so imagine in this story of the carbon emissions tracking and monitoring, imagine we were streaming this data, we were tracking and monitoring this data, we had even included this in reports that we sent to a centralized authority for a oversight check to get approval that we were in compliance. And now all of a sudden, we read the data again, and the data is different from where it was that we last reported. Maybe we need to calculate some month-over-month changes. Maybe we needed to calculate some other things. And we see that, imagine this time range, this timestamp that was down here. Imagine this was September's data. And previously we said it was one value. Now we query it again, and it's different all of a sudden. So what could be wrong? Is it late arriving data from our sensors? Of course, that's a very valid thing it could be. Is it duplicate data, incorrect data? Let's get into it and see what we can uncover. So first we just select it from our table as is. So this is the state at which we have it right now. So I paused the stream so we can keep track here. So we have these spikes that are happening. Let's maybe look at one particular spike here. Let's look at this one for the timestamp that ends with 54278. 54278. Let's take a peek at that. And here for this particular timestamp, I see that, let's look over here. There's two different device IDs. This one has 2 rows though, and let's see, it's at the same timestamp, the same device ID sent, let's see if it's the same value. Yep, the same value, 1552 of the CO2 level. I wonder what could be wrong here. We need to debug it a little bit further. Maybe I spot this though. Maybe I spot here that, hey, the device name has changed. So maybe I look through some other DevOps audit history. Maybe I have to call up a few other engineers upstream to learn what happened with this. But let's say that I come to find out that there were some firmware updates on the devices which ended up changing the names of those devices. And then something in the uploader thought that this was new data that was available. It had it in the buffer stream, and it said, oh, this is new data. One of the values is different in the row. We need to send it up again. And now duplicate data just flooded into my system, corrupted my data. So let's use time travel to find an older version, and just, because I swear we were watching that stream, everything was kind of even, and then all of a sudden previous values popped up a little higher. So let's look through the table history here. And let's say that the firmware update we found was near this timestamp. Oops. Let's say the firmware update was a little after this timestamp. So let's travel back in time with this timestamp and take a peek. All right, so we can see it at the flat line. Let's pick one of these peaks in particular. This timestamp ends in 54283. 54283, and up above here, 54283 is right down here. That one's actually a lower value, but I think you get the idea. In between those ranges, these ones were duplicated and had doubled in that range. So now let's write a query that shows us the unique difference between these two versions. So I did this with a left outer join, comparing the device name and the timestamp, and checking, kind of doing that anti-join to see just the difference. Let's run this. Let me paste the new timestamp in here. It's taking a little longer than expected. After this cell executes, we're going to see a line that's kind of on its own, and then we're going to see all of the device types together. And what this is representing is, of course, because we're querying an older version of the table. This table didn't have all of the new records and the good records, the clean records that were pumped in. So we're going to see on this line chart, once it loads, the duplicate data that's separated, and you'll see it distinctly, and then the new data as it comes through. And if that's taken too long. While it plays catch up, I have a static version that we can look at here. All right, here's an example of what that would look like as it finishes. That one just took me 5 seconds to run. But you can see that there's this line of just the meters. It was just the meters that had the firmware update that changed the name and pumped duplicate data. You can see those are kind of on their own there. And in line, they're not extreme values or anything like that. And then this grouping of all the other device types, this is the new data that was pumped, the good data that was pumped after this particular timestamp at which we traveled back in time to look at. So now how are we going to clean this? How are we going to merge it back in so that we can get rid of that bad portion of the data but keep all the new good information still there? So we can use a merge into syntax, merging into that same clean table, using the diff. You can see that I created a temp view so I don't have to repeat this logic here. Using that diff, and we can join on the device ID, because the device ID stayed the same, but the device name is what changed. And so we can compare the differences there, and when we get a match, we can actually say just delete those rows altogether. So after we apply that, let's see, it probably came back to catch up with us. There it is, great. We can delete the rows and then check it out as it's cleaned up. Okay, we processed the delete. And now we can see that stream is cleaned up to what we expect. So up above here, let's peek at them again. We had these extreme values, double pump data that had snuck into the system. We looked back in time, we didn't see it was there. And now we were able to, using time travel, correct this data, merge it back in, and get the stream to clean back up again. So that was the quick example there. I'll show one more slide and then we'll open up for some Q&A as well. So here's just a couple of friendly links if you want to use. Delta.io, obviously the best place for the documentation on Delta Lake and time travel. There's also some community discussion channels there, in case you weren't aware. There's both a Slack channel and a Google user groups. Those are very active, a lot of participation from community members and Databricks and other people that commit to Delta Lake. Of course, if you wanted to follow what's new on Azure Databricks, there's a couple links there also. So that concludes my presentation today. Hopefully you see and could brainstorm a couple new ways that you could use time travel. Hopefully you understand the concepts about how time travel is possible with Delta Lake and learn something new in that regard. So I'd love to hear some questions from you on the mics, and I'll also stick around afterwards. I know it's lunchtime afterwards as well, so if anyone wants to go to lunch and chat about some of these things, happy to do that also. So Giri, if you want to open up those mics.
Yeah. Hi, thank you for a great presentation. So my question is on the kind of reasonable time that you would want to like store the history, because as you mentioned, one like possible use case for storing these older version of the data sets would be to run, let's say, machine learning on an older version.
Yes.
On the other hand, from what I've learned from Databricks, if you would want to store a very long time, like let's say a year or 10 years, you'll get an explosion of the transaction log. So what's your and then the other option of solving this issue would be to then have some sort of data modeling that would take care of the data versioning. So what's your take on the reasonable amount of time that you could you do with just Delta Lake's time travel?
Yeah, great question. Thanks for asking. So there are just a couple principles to make sure everyone's on the same page. He mentioned clearly that it is the transaction log. As you would store data, or as you would store history for a long period of time, say a year, multiple years, you could go to some extreme case. What is going to expand and grow is the transaction log. And that's keeping a record of all of the changes that it takes to create the latest version of your table. So in the short term of storing these, the transaction log is much smaller than the actual data itself. It's much smaller in comparison, relatively so. But then you're right, as you think about what's realistic and practical and how long I want to save this data for. A couple of other principles, by default, you are saving 7 days worth of data. That's the default configuration. Of course, you can change that all the way down to 0, although not recommended in production. And you can push it. I don't think there's any upper limit on the configuration that you can set. But there are some maybe practical considerations you would keep in mind. Of course, that transaction log is going to grow very large, so there may be some performance implications as you try to query that if you're trying to save multiple years of transaction history. So perhaps it depends kind of on your business case and where you would be, but perhaps you may come up with, and I think you were alluding to it also, a case where you would save the data, like maybe you save a monthly snapshot just in your raw storage. And then you wouldn't have to keep that transaction log going for such a long period of time. So depending on your use case, if a monthly grain is sufficient, and you want to save out to like 5-10 years, something like that, that could be practical. If you're saving much further and you want to optimize on the cost in your storage, maybe you do it at 6-month, quarterly kind of snapshot cycles. Then you don't get as fine-grained like debugging in between, but at least it's a way you can think of, hey, I've got this transaction log, I can really quickly ad hoc go back. You can see from the exercise that we did, time travel and do it ad hoc that way. But also I can save more regular versions as I go. Does that help? Okay, great. Yeah.
Hello?
I think I heard you.
It's on.
Yeah.
Cool. Thanks for a nice presentation. I'm Eric from Vattenfall Trading in Hamburg. And I might have a rather simple question, but I'm interested in you talking about moving from the raw data format to the delta data format in these conceptual bronze, silver, and gold zones.
Yep.
Is there a given format when you say moving from a raw to a delta format? Have you sort of thought out best format for storing data in a data lake?
And by format, do you mean like a Parquet or otherwise?
I mean, which kind of metadata you need to save, which kind of, how you represent values, how you represent date strings and so on.
Yeah, I think those would be mostly dependent on your business and your applications. You could, of course, analyze if you needed a better compression and smaller space of storage. You can analyze different types and see if you can squeeze some cost savings out of that as well. I just wanted to check at the beginning of the question as well. It's always going to be in a Parquet file format. But if you're talking about like individual types for the data, I think it would totally be dependent on your business case. If you need things available as strings, if you need them, of course, as date time objects, I think it totally depends.
Well, basically, we are working with time series.
Yep.
Because it's energy markets and, for example, the EUA market, good example. And we have lots of different business areas in Vattenfall, and they all want to store their data in their own way.
Yep.
And I would like to use all the data in the whole company for AI.
Yeah, so maybe, that's a good point. And part of it's about democratizing that data, getting organizations aligned, right? You guys rated that as a top blocker, right? So some of it would come into play in that organization factor. Can you decide, do you have a central authority that can even dictate or create APIs that control and manage what those types are? And if so, then maybe that person has to work with the various stakeholders to understand, is this type format going to be the right for all the various applications? And if not, maybe I need a couple variants. So it might come through some of like a centralized organization strategy. Does that help? We can chat some more after if you want
we can.
to,
It kind of outlines the problem that we're having.
Okay, cool.
Thank you.
All right, cool.
Any more questions? Hi, nice presentation.
Thank you.
Just two questions. First, regarding the diagram that you had for the bronze one.
Yeah.
You recommended, for storing it in Delta Lake. Yeah. Now, in Delta Lake, behind the scenes is Parquet.
Yep.
And if I remember the slide well, the streaming source went directly into the bronze one. So the question is, with regards to Avro and Parquet, the difference is that Avro supports, better schema evolution than Parquet. Parquet would only, say, support column addition, because if you do merge schema, whereas Avro can handle a lot more situations. So would you still then recommend Delta format for the bronze table instead of an Avro file?
Yeah.
That's the first. And the second question is, I have played around a little bit with time travel, not used it in production so far. But the one thing that I found was when you actually try to find the versions of the data that are there, you have to use the exact timestamp.
Sure.
You cannot use, say, for example, one you have on the 15th, one you have on the 17th.
Sure.
You cannot just say 16th. Is that by design, or is that going to change?
Yeah. Good questions. Let's tackle the second one maybe a little bit easier, and then we'll go to the next, and I'll go fast so that we can answer. We'll go just a few seconds over time. But the second question being about selecting the exact timestamps. You're right, you have to select the exact timestamps as of today. Perhaps that would change in the future. But there's other methods that you can use if you didn't want to query the history and try to extract the exact value that you wanted. I think one of the previous slides showed an example of you could say, you could say, go back in time to the previous version, like you did a current version -1. You could do a current version -10, then you're kind of guessing at those timestamps at that point. But there's a couple other techniques that you could use to make it so that you didn't have to find that exact timestamp to get there. So you could list those and sort them and pick the third, pick the fifth. You could do a couple of things like that. Then your first question was about the format and Avro maybe versus Delta versus Delta format and what would you pick between there? You mentioned one key aspect of Avro when it came to the schema evolution and schema management. One thing I didn't talk about so much with Delta is the schema enforcement. I think in the keynote they had some demo on that. I think it was Barak that showed that he tried to change the schema and it prevented him or didn't allow him to do so. So that can help you if you have upstream providers that all of a sudden change the schema out from underneath you. You can help prevent for some of those type of things. So you want to weigh I don't know all of the aspects of Avro in itself, but you'll have to weigh those trade-offs versus also what you get with Delta format. To see which one better suits your needs. From there, to mention, there's a couple other things that are being built out in Delta. One's called expectations, and a way for you to set expectations of what the data should be or what ranges it should be, and then you can filter out, break the processing, or quarantine some data as it comes through. So, I mean, if I was picking and choosing, and I kind of had to hedge my bets or pick one basket, I would personally lean towards Delta. But of course, it would be you'd want to evaluate for your particular need. So I think we're out of time on the questions. So I'm going to stick around after for a little, and we can go to lunch if anyone wants to grab lunch. And thank you very much.
Thanks, Kyle, for a nice presentation.